Hi guys, and welcome back. I hope you're all enjoying the show as much as I am. I'm learning lots, and we've been chatting during the break, and I think I'm starting to understand, which is a thumbs up for me. I just want to say hello to Anele, because Anele, I haven't seen you forever, so I'm glad to see that you are on the Facebook page. And then there's Pleasure as well, and Robin, and Mondi. Hello Mondi, and hello Michael. So I just wanted to say hello to all of you guys, and also remind you that we also give away one labeler on a Monday and one labeler on a Tuesday. So this goes to like the ultimate mindsetter. So these labelers go to the mindsetters that are chatting to us on the page each and every single day and are helping out each other on the community. And if you want to get this awesome prize and maybe even win this awesome calculator, what you need to do is you need to chat to us on Facebook, and it's facebook.com/learnextra, and it's all about learning. That's what we're trying to do. So post any questions, help each other out, post inspiration. That's what it is about, guys. This community is for all of us. Together we are team mindset. So E.T., now that I'm talking so much, it's back to you for the lesson.
Thanks, Inde. I think you said one of the students asked about qualitative data and
yeah, the quantitative. Do you want me to read the question?
Yeah, read out the question.
Let me read the question.
Yeah.
Okay, so now this one is from Pleasure, and Pleasure says, okay, let's see if I can get this right. I have read it to ET. If they say sets of data, qualitative or quantitative, if they are quantitative and state whether they are discrete or continuous, for example, A, shoe size of grade 10 learners in your school.
All right, I think I had one of the slides when I started, and that's exactly why I defined these things. I said if data is quantitative, it's something you can measure, and when you can measure, it's called continuous. Things like the length or your height, or even your weight, okay? So those are the things that you can measure. And discrete data is data that you can, you know, to collect it, you have to count, okay? You have to count the number of cars, or the number of cows, or the number of horses, the number of shoes. I think that's what, you know, the example we have here. So as long as you're going to count, that is discrete data. Okay, I hope that
that clears it up completely.
Yeah? Great stuff. Okay, I'm sure we can proceed. Some of you may have worked out the angles from the question that I was doing here, may have worked out the angles, and you've already drawn your own pie chart. I would like it to be your exercise. All right, so I'll move on to the next graphical representation, which I call the bar graph. Yes, it's called the bar graph or the bar chart. All right, let me pick a pen there. So, next in our graphical representation is a bar graph. A bar graph basically represents discrete data. There comes that thing about the type of data now. So I'm saying here, a bar graph represents, represent the following as discrete data on a bar chart. Okay, you will see later that I'll distinguish this with a histogram, which deals with continuous data. So what you're having here, I think this one, maybe I should also give it to you as an exercise, because I'm trying to just basically, this week I said, I'm going to try and cover the definition so that next week I can actually be drawing these graphs and all those kind of things. And questions, I can answer questions from you. I'll prepare some other questions as well. But yeah, I've given you this information. If I can read it out, those who are writing, you've got items A, B, C, D, E, F, G, H, and I. And what has been counted? Okay, you've got the frequency about them, which is 21, 25, 30, 32, 33, 33, 34, 45, and 47. So now with the bar graph, you are actually going to plot on the vertical axis will be your frequency or the actual measurement. All right. So your frequency there, and right here at the bottom, you will then list your items. C, D, and E like that. Now, how does a bar graph look like? So you will basically pull it up like that, 30, 21. Let me just scale this properly so that I don't get short here. So if this is about 21 and 30, 47. All right, let's just extend this a bit. So that's our frequency there. So if this is about 20, that's about 40 there. This is 21. All right. So this will be A, and B must not touch with A. So it's going to come out somewhere there as 25, probably landing up there. Okay. So all I'm doing is, why is it called a bar chart? Those are just the, you see those rectangular bars that you have over there? That's why it's called a bar chart. So the C is going to be 30, somewhere there halfway between, did I say 40 there? Yeah, 40 and 20 there. So somewhere almost halfway, that's a 30. Yes. So then you have your next bar there. Okay. And for D, your bar will be at 32. So this will then carry on like that. For the other items, if I can just complete the E, also close to that. So what you will notice, therefore, is that between these bars, there is a gap. I left a gap. Why did I do that? Because this is discrete data. All right. Over there. Typical discrete data, again, could be the months, for instance, the January, February, up to December as well. All right, so that's how your bar chart would look like, basically. All right, and on top of that, you can be asked about the central tendency of data. So things like the mode and the mean, you know, and the median, you can still be asked from the graphical information. You know, you may still be asked the same kind of question. All right. So let me move on to the next chart because I'm trying to cover all of them here, if I can. Next is your histogram. What some people call the frequency, well, not necessarily that. So it's the histogram. The histogram, how does it differ with the bar chart? The histogram basically represents continuous data. So if I give you continuous data, you know, like in this case, you draw something that is called a histogram, but it's going to look exactly like a bar chart, except that you are going to have the bars that don't leave a gap in between. Okay, probably that one goes up to there, the other one goes up to there. So that would be a typical, you know, histogram. And I have indicated in brackets here in the frequency polygon. I want to say for a frequency polygon, if this was the frequency as given here, these values, so you would basically join the midpoints of your what do you call it again, the items, and then in this case the mid value of 10 and 15, for instance, that would be about 12,5. So you then join those values, I mean those points. So let's say the other one was there. And yeah, depending where you started with this data, you may have to have an artificial point, you know, in the end so that you complete your polygon. Okay, so this is what a histogram is about. So associate a histogram with continuous data, associate a bar graph with discrete data. All right, and what else do I have to cover there? I think most of you, you know, will have learned about a line graph anyway. So that's one of the way we can represent our data. So we'll simply plot, if we call this, let's say, typically we have X and Y, you know, we have X and Y. So we can say this is now a table of X and Y values. And all you have to do is, the normal way you plot your rectangular coordinates, X and Y, that's what you will do here. So you will take that to be Y, and that to be X, and you will plot points as given. So you read out the X value and the Y value, and you mark a point. You mark a point and continue just like that. Okay. In this case, in fact, another one that you'll come across is called the Scatterplot. So, but what I've represented here is actually a Scatterplot. But if you join the segments, you know, let's go up there. If you join the segments, you know, so on. So we call it the XY plot, okay, because you're dealing with the X and the Y. All right, so pretty straightforward as well. Then we can move on to the next type of representation that you can have. It's called the stem and leaf. Stem and leaf diagram. This one basically, it takes from your, okay, so you basically take your data and in doing the frequency diagram, you say, let's say in this case, those starting with the 1, yeah, let's see, the 2 for this group, and the 3 for that group, the 4, then the 5. So basically those are just you put at the starting point, 3, 4, 5, and you basically write the numbers that follow. So in this case 0, the other one is 0, 1, 5, 9. The beauty of this thing is that you are plotting the frequency, but you do not lose the information about the actual values. All right. So you would carry on like that, and that's what you call the stem and leaf diagram. And if I can just, I think the last one I wanted to just mention quickly is the cumulative frequency diagram. You'll come across the term called the archive sometime, but maybe this we should leave for next week when we
let us do that.
Questions, right?
Okay, yeah. So
Yeah.
guys, if you do have any questions, just post them on the page. I can't believe we've come to the end of the lesson. Exactly like Doctor said. Doctor said time is my top enemy, and that's exactly what it is. It's just like an hour is just not enough.
Yeah,
So guys,
yeah.
post all those questions, and we'll be helping you out on the page and help each other. Thank you, Mindsetters, for an awesome Learn Extra live show. Thank you, Liberty, for an awesome show. You guys rock. See you same time, same place next week. Grade 11s, don't forget that you're up next. Thanks for a rockin' show. See you next week. Bye.